I'll show you how to use the full functionality of the TI calculator to find a confidence interval for a proportion. Here's a simple little problem. In a recent poll of 1,002 likely voters, candidate A received 450 votes. Okay, so our first question is it appropriate to use the normal distribution for calculating a confidence interval? Remember, to use the normal distribution, you have to have at least 10 successes and at least 10 failures. In this scenario, a success means we found a voter who is most likely going to vote for candidate A. In fact, we found 450 of those guys. So that's 450 successes. The rest are failures. And so we can say that there are 450 successes and 552 failures. Both are greater than or equal to 10. So the normal approximation for the sampling distribution of the proportion of voters likely to favor candidate A is appropriate. Based on this sample, determine the 95% confidence interval for the proportion of likely voters in the population that will vote for candidate A. Use the full functionality of the TI graphing calculator. So we find our function that we need under the Stat button in the menu item Tests. So we navigate over to Tests. Be very careful that you select an interval option, not a test option. Since we're working with a proportion and we have one sample, we have one proportion, and we're going to calculate a z-interval. It's option A. We see all the way up to option 9. To get option A, you can use the alpha key, and then the key that has the letter A is this key. You can see the A right there. So if I just select alpha A, calculator will go to the function 1 prop z-int. If you can't remember that it's under alpha A, then I'll show you how to get there. If you can't remember, just use the Stat button, navigate over to Tests, and then just scroll down until you see the test or the interval option that you want. The interval option we're looking for, remember, is 1 prop z-int. There it is, 1 prop z-int. We have one proportion to estimate, and we're using the normal approximation, which depends on z-scores, to find a confidence interval. So that's what the abbreviated name means. The calculator requires some inputs. It wants to know x, and x is the number of successes, and in this case that's 450, so we enter the number 450. This has to be a whole number. You can't enter a decimal part here. X must be a whole number. N is the sample size, and in this case that's 1,002. So we enter 1,002. Our confidence level is 95%, and you can enter 95 or 0.95. The calculator doesn't care. That's very strange, but it's how it works. Now just calculate. And here's the output. The output is the confidence interval, unrounded, 4 digits. It also tells you what p hat is. You see the little hat right there. There's p hat. It tells you what p hat is and reminds you what the sample size is. So that's our confidence interval. And we are expressing that in interval notation, properly rounded. So let's talk about the rounding. The first left endpoint, or the lower bound, is given as 0.4183. We want to round that to 3 decimal places. So the 3 will round off, and we'll end up with 0.418. The upper bound is 0.4799. So this 9 will cause that 9 to round up to a 10. And so we put a 0 there, and that 0 is a significant 0. It's a 0 we got from our rounded value. So we're going to keep that 0 and round that 7 up to an 8. And so our rounded upper bound should be expressed as 0.480. This 0 is significant. The 0 here is not significant. You can take that 0 off and it doesn't change the number at all or change the precision of the number. But this 0 here is significant because it tells us something about how precise our number is. So we'll keep that 0 that we obtained from rounding. What is the margin of error for your confidence interval? Well, remembering that the margin of error is simply obtained, well, is actually twice as long. There's a margin of error on either side of your center here. So the margin of error, to find that, you would find the length of this interval and then just divide that by 2. So the margin of error, and I chose to use percents in my calculation. You could use the decimal numbers. It doesn't really matter. But the margin of error is the upper bound, 48%, minus the lower bound, 41.8%. That's the length. Divide that by 2 to get the margin of error, and the margin of error is 3.4%. Write a sentence that interprets the margin of error. Well, remember that the margin of error just tells us how far away or what value we are within the actual population proportion. So we know that we're within 3.4% of the actual population proportion with any estimate that we get from a sample of size 1002. Okay, so that means that 95% of the sample proportions from random samples of size 1002 will be within 3.4% of the population proportion. So let's analyze the sentence. So we're taking random samples of size 1002, and we know since we have a 95% confidence level, we know that if we repeat that process multiple times and calculate many confidence intervals from samples of size 1002, that 95% of those confidence intervals will actually contain the true population proportion, which means that 95% of the sample proportions that we get this way will be within 3.4% of the population proportion. Well, that's how we interpret that confidence interval. That margin of error. Now we're going to write a sentence that interprets the confidence interval. It's a little bit different wording when you're interpreting the confidence interval. So the confidence interval tells us how likely it is that we've got an interval that actually contains the true population proportion. And so when we interpret the confidence interval, we say we are 95% confident that the proportion of likely voters who favor candidate A is between 41.8% and 48%. So that's all there is to it. Remember that you can watch this video over and over again. Have fun practicing.